All right, we're back. We are on Notes 10 of Calc AB, and we were talking about derivatives and function analysis. This is actually kind of a review if you took math analysis. So what you should do is bust out your math analysis notes, notes 22. There's a playlist of me doing all of those notes. It's incredibly long. But if you want to get into the real details of it for the first time, that's the place to start. I'm going to kind of assume you know a lot of this stuff and go through it with that in mind. So let's see if we can do this. So that's notes 22 math analysis. If I remember, I'll put a link in the description, but I probably won't remember because I knock out a lot of these videos at a time. So who knows? All right, let's see. So derivatives and function analysis, it's all about increasing, decreasing, concave up, concave down, that kind of thing. So first, what does it mean for something to be increasing? So this is the Algebra 2 definition of increasing, decreasing, which is really like where the definition comes into play. And so it's important to realize that like the definition of increasing, decreasing is not really a calculus thing. It's more like if you move from left to right, are you walking uphill or downhill type of thing. And if you look at it, the first thing here, function is increasing on an interval if for all x in the interval, if x2 is bigger than x1, which means that you're just moving from left to right, because on the x-axis, if a number is bigger than another number, it's to the right of it. So if you're moving from left to right, f of x2 is bigger than f of x1. It's just telling you as you move from left to right. So as you move left to right, y gets bigger. I'm gonna write uphill. You just go uphill. I was thinking of a two-dimensional platformer type game where you're walking from the left to the right, you're going uphill, increasing. And then decreasing is basically the opposite, right? So you're still moving from left to right. You're always going left to right, but you're going downhill. So that's really all there is to it. But you might notice that you need to be able to move from left to right. So that's going to be an issue when we talk about increasing or decreasing at an endpoint of an interval. Is it increasing at an endpoint? Is it decreasing? Well, you can't really move from left to right at those points. So like we'll have to decide what we want to do. I'm mostly just going to not include the endpoints, but an issue we will have to deal with. So moving from left to right, always the thing. There's some description here of how this connects to the derivative. So if x2 is greater than x1, then we know that this is definitely positive. And if we know that f of x2 is greater than f of x1, then we know that when we subtract these, also positive, which means so the secant line is positive, right? But what do we always do in calculus? In calculus, we're always basically taking the denominator and letting it approach zero. That's kind of like an idea that's really a part of derivatives. So if we let this part approach zero, this slope is still going to stay positive because you're always doing bigger things minus smaller things. So you're always getting positives. So when we take the limit as this approaches zero, this actually becomes, well, this part becomes the definition of the derivative. So we can use derivatives to tell us if a function is increasing or decreasing at a particular point. So let's make sure you remember, because this is math analysis notes 22. Let's make sure you remember this. So a function is increasing at a point if f prime is greater than 0. And a function is decreasing at a point if f prime at that point is less than 0. Huge idea, just like enormous. You're going to use it all the time. You're going to use it so much that you never really need to think about it, but make sure you know it so that you can think about it, so that you can feel like you don't have to think about it. So if we look at this, this is a graph of determine the sign of the first derivative of the function based on the graph of the function. So this is a graph of f of x. So big deal going forward is what graph are you looking at? Are you looking at the graph of f, f prime, f double prime? You have to know, because if you don't know, then there's no way to figure out what to do. So the sign of the first derivative, okay, so anywhere this graph, f of x, is decreasing, f prime will be negative. So I'll use two different colors. So I'm going to highlight in this color is going to be decreasing, and then this color is going to be increasing. Okay, and then, oh, wait, hold on. You gotta be really specific, like what's decreasing? So I'm gonna say f is decreasing, and then f prime will be negative, and then f is increasing, so f prime will be positive. Okay, So here we go. I need f is decreasing. So if f is decreasing clearly from A to B, it's like coming up with that scheme took more time than doing this problem. Decreasing. All right, so that means that f is decreasing, f prime is negative. So I mean, I'll write it just to start hammering it into your brain. And then let's do our increasing. So f is increasing because as I move from left to right, the y values get bigger. And then here, as I move from left to right, the y values get bigger. So on these intervals, f prime is going to be positive, f prime is going to be positive. Okay, so that's like the basic introduction. And it's like not a trivial thing. Being able to do this is on the way to being great at doing all of this. So thinking about the functions that you already know, look at them, decide where they're increasing, decreasing, and just know that means the derivative would be positive. That means the derivative would be negative, right? Create a graph on your calculator, look at it, say at x equals 3, this graph is increasing, then use your calculator to find f prime of whatever number I just said, maybe 3, and see if it's positive, right? That's how you get better at these things. So go do some of that. I will be back in the next video to keep going, so I will see you there.